I'm Shiro Kawabata from AIST Japan. So today I'd like to talk about the national quantum strategy in Japan and also our brand new quantum center in AIST. Actually, AIST is a kind of the national institute, especially focusing on the engineering. So like Fraunhofer in Germany. And today I'd like to talk about this brand new quantum center. So can you switch to my presentation slide? So actually in Japanese government, actually established three national quantum strategy. So first one is this one, quantum technology and innovation strategy. This was published in 2020, almost 3 years ago. And this strategy is mostly for the R&D, research and development. And because of the very rapid progress of the quantum technology in the world, so Japanese government decided to make the vision of the quantum future society. So this was established in 2022 and last year. And later on this year, so Japanese government released the strategy of the quantum future industry development. This is mostly for the commercialization and industry and academia collaboration and so on and so forth. So then so Japanese government actually decided to make the very challenging goal for by 2030. First one is the 10 million quantum technology user in Japan. Okay, you see it's very challenging. And also the second one is 50 trillion in production value from quantum technology, and also creating the quantum unicorn startups. So in Japan. So this is a Japanese strategy. So then, yes, and based on these three strategies, so Japanese government decided to make the totally 11 quantum research hub in Japan. So this is a list of the quantum hub in Japan. Actually, the headquarters of this quantum innovation hub, QIH, is Riken. So then the other is like the AIST, our institute, and Osaka University, and the University of Tokyo, and so on and so forth. There are many innovation hubs. And most of the hub is mostly focusing on the research and development. On the other hand, in our institute, AIST is focusing on the commercialization and industrial academia collaboration for the quantum technology in Japan. So this is, and then based on this, so we have developed, based on the national quantum strategy in Japan, so actually we have quite recently developed brand new quantum center in AIST. That is AIST Global R&D Center for Business by Quantum AI Technology, so-called GQuat. So then that is actually established in the last July. And this is the structure of this GQuat, and we have totally 6 research teams. And the first 2 is mostly for the quantum AI hybrid cloud system and use case creation. And third and fourth team are mostly for the quantum hardware test bed. So this kind of test bed was already discussed by the previous speaker. And in Japan, we will develop the quantum hardware test bed. First one is mostly for the quantum computer itself, like the superconducting qubit and the silicon qubit and so forth. And second one is a very specific and very characteristic test bed. That is a test bed, low temperature test bed for the actual component of the quantum computer in the dilution refrigerator, like the amplifier and cable and also the filter and so on and so forth. And last 2 is mostly for the fabrication. We call it quantum pilot line. Actually, we have 2 teams for making the superconducting with silicon quantum computer and also the diamond quantum sensor and so on and so forth. Okay, this is the structure. And then, okay, this is a plan of this GQuat actually. So we have 4 important actual functions. The first one, the quantum AI hybrid cloud application, and second is the quantum hardware and component test bed. And also the third one, the quantum fabrication pilot line for the quantum hardware. And last one is, of course, based on these two functions. So we will have a kind of the global quantum industry human resource development for the future quantum workforce. Okay. So this is our goal is towards the global industries support actually. So this global is very important for our Z-Quad. So then based on our technology for the architecture and algorithm, and we will provide quantum AI hybrid cloud system, and to create the future application and use case exploration together with the industries. And also based on our integration technology for so we will develop a quantum hardware and component test bed. And later I will tell you the detail of this kind of infrastructure. And also based on our fabrication technology for the superconducting and quantum silicon and CMOS, and also the diamond technology. So we will provide quantum device pilot line. So then to make the high quality qubit and also the large scale integration of the quantum circuit and so on and so forth. So I will tell you the detail of these three infrastructure. First one is the quantum AI computing hybrid quantum computing platform. So we already have a so-called ABCI. That is the name of the AI-based classical, the GPU-based computing infrastructure. So we are now trying to update this ABCI to ABCI Q. So Q means that the quantum, and this is because that we will connect this classical AI supercomputer system to the actual quantum computer, like the quantum annealer and also the quantum computer, superconducting and the silicon and so on and so forth. In addition to that, we will also install the quantum circuit simulator. Actually, we already installed the NVIDIA Q quantum circuit simulator in our ABCI, and also we will install the classical simulated annealing-based annealing software into this ABCI. So based on this infrastructure, we will try to create the use case, industrial use case, and together with many companies, startup, and also the university and research institute in the world. Okay. And second one is test bed, actually. There are two test beds. So first one is a quantum hardware test bed. So we are, as you know, in order to operate the quantum computer, especially the superconducting and also the silicon semiconductor CMOS-based quantum computer, we need dilution refrigerator. And actually, we will install the special dilution refrigerator, which can be used up to the 1,000 qubit. So then this is now in progress. And also but this kind of test bed is already exists in the world. And second one is very important and very specific in AIST. Actually, the AIST is the National Institute. In AIST, many scientists and researchers are working with the methodology. Okay, so then some of them are trying to contribute this low temperature component test bed. Okay, so as you know, inside the dilution refrigerator, there are a lot of the components, like the package, cable, connector, circulator, amplifier, and filter, and attenuator, and so on and so forth. A lot of the components are working inside the dilution refrigerator. So there's many of them are actually made in Japan. Many of them are made by the very small and intermediate scale Japanese company. But problem is that such company don't have the dilution refrigerator. So they cannot evaluate their own product. So then we have decided to make the special test bed for this kind of the component and material. Okay, so then we will make to make guarantee for the low temperature operation. Okay, so this is our test bed, and third one is the fabrication, and that is a quantum pilot line. So this kind of the pilot line is now planned in, for instance, EU. So Q pilot project, maybe many of you know. In Japan, we already established the quantum pilot line. For first one is for the superconducting quantum circuit, and also superconducting detector, and also the superconducting control circuit for the quantum computer, like SFQ and HFP based. And this is called QFAB. Okay? The second one is a Colomode. Its name was a pilot line. And this is mostly for the silicon quantum bit and silicon quantum circuit, and also the cryogenic CMOS circuit. Okay? We already established two pilot lines for the quantum hardware. Okay? So we will provide the service for this two pilot lines for public, actually, in the world. Okay? And so before closing my talk, so we would like to briefly mention about our AIST activity on the quantum computer. So actually, we have many actually the scientists and researchers working on the quantum computer, and mostly for the superconducting one and the silicon one. And actually, as for the superconducting quantum computer, we have recently published several articles on the, for instance, the initialization of the superconducting transmon qubit using the quantum circuit refrigerator. And also we also have established a technology for the making the nitride-based epitaxial qubit, which can be used for the very high quality quantum bit. And also we have recently realized superconducting quantum annealer up to 32 qubit. And also we also have working on the silicon quantum computer using the tunnel FET and also the FinFET type qubit. So in addition, also we also working with working on the flying electron qubit on the surface acoustic wave, and also the many theoretician and simulation guides working on the theory for quantum algorithm, and also the modeling of the superconducting bosonic qubit, and so on and so forth. Okay. Okay. So then our final goal is to realize a global business quantum ecosystem through GQuad. Actually, in this sense, the international collaboration is really important for us. So then, if you want to join and collaborate, please contact to me. And actually, by contacting to the collaborating GQuad, you can access to the Japanese quantum community, like the quantum company and the quantum startup, and also the quantum many university and university and the National Institute working on the quantum computer and quantum technology in Japan. So then, okay, this is the final slide. Yes. So then the international collaboration is really important. So please contact to this address. So thank you very much.